everyone who happens to be listening to this lesson today. I have good news, I guess, to start with. Today is the last day of Chapter 9, which is good news because Chapter 9 is the last, really technical chapter in this class. So thanks for trudging through this with me. Once we finish up Chapter 9, we're going to start getting into chapters that are a little bit more intuition-based, and there's kind of a little bit more storytelling. So one last class to push through, and then we'll be kind of in happier territory. So to just remind you where we left off last class, we were looking at the Rothschild-Stiglitz model, and we said that there's only one kind of area within an IHIS space where it would be feasible to have contracts that exist such that those contracts wouldn't result in a death spiral. And those contracts all reside within this area called the feasible contract wedge. The big caveat is that while all of the contracts within the wedge could feasibly exist, there's only going to be one contract within the wedge that would ever be an equilibrium contract, or in other words, it would be a contract where the market could just perpetually be in a position of consumers buying that contract, insurance companies selling that contract without any kind of deviation from that particular contract. Okay, so one of the assumptions that we made last class was that all of the consumers of insurance are homogeneous, or they're the same. That's not realistic. So in the real world, different people have different probabilities of getting sick. And so what we're going to do for this last little segment of Chapter 9 is we're going to have the model acknowledge that in the real world people differ in terms of their health. And then let's see if we can still keep the market in a position where it's operating and not running into a death spiral, given that we're going to have different types of consumers. Okay, so what we're going to do now is we're going to relax the assumption that all consumers are homogeneous. And specifically, we're going to assume, for simplicity, there are two types of consumers, and these two types of consumers differ only in terms of their probability of getting sick. We're going to call the two types robust and frail. The robust types are going to be the people who are relatively healthy. The frail types are going to be the people who are relatively sick. Okay, robust probability of getting sick is going to be denoted P subscript R, and frail's probability of getting sick is going to be denoted P subscript F. Okay, just kind of engage a little bit instead of staring at the page and think about what should be true about the relative magnitudes of these two P's if robust is healthier. So if robust is healthier, then that means he should have a lower probability of getting sick. So what this is going to mean for us is that PR is going to be less than PF. The reason this is important is because a person's probability of getting sick influences their expected income, and a person's expected income in the Rothschild-Stiglitz model determines where the person's zero profit line is. So if what is true is that PR is less than PF, then this implies that the expected income for robust is going to be greater than the expected income for frail when they're uninsured, so before they have purchased any contract. Okay, a divergence of the two types' expected income is going to mean that there's going to be a divergence in the two types' zero profit lines. So if robust has a higher expected income, then that means that when we plot robust zero profit line, it should be steeper because it needs to hit the full insurance line at a position that's relatively high up compared to the frail type. So the frail type, on the other hand, he has a pretty good chance of getting sick, so his expected income is going to be kind of low, and so his zero profit line is going to be flatter or have a slope that's less steep because it's going to intersect the full insurance line at a lower position. Okay, just note that the origin of both types' zero profit lines is the same, so we're still starting from the same dot. And the reason for that is because the assumption that we made is that the two consumers only differ in terms of their probability of getting sick. And that means that their original incomes in the event they get sick or stay healthy are going to be the same. So, in other words, kind of the hit that their finances would take is congruent across the two types. It's just the probability that their finances are going to take a hit that now differs between the two types. Okay, so What that means, based on what we learned last class, is that each type will have a different equilibrium contract. Again, an equilibrium contract, well, what we found out last class was that an equilibrium contract is going to be one that is full and fair. And so for the robust type, his full fair contract would be the intersection of the full insurance line and his zero profit line. So his equilibrium contract would be the sun that's kind of up at the top. But for the frail type, his equilibrium contract, which is full and fair, would be at the position where his zero profit line intersects the full insurance line, which gives you the point or the sun that's kind of closer to the bottom. Okay, here's the point where we need to kind of think about how the real world works. If insurance companies could differentiate between robust and frail, and if they could legally exclude certain people from certain contracts, a stable equilibrium would be to sell the top sun to robust people and the bottom sun to frail people. But they can't do this, and the reason they can't do this is because in the real world there exists asymmetric information. So let me unpack this for a minute. The idea is, suppose you are an insurance agent and you are offering two contracts. You've got the top sun contract, the bottom sun contract, and you have a customer who walks into your office and they say, I would like to buy insurance today. Well, you whip out the two contracts. You say, we've got top sun, we've got bottom sun. The problem is, because there's asymmetric information, you as the insurance company can't look at this person who walked in your office and just tell off the bat whether they're robust or frail. If you could, then if the frail person happened to walk in, you would just show him the one lower sun contract, because that would be his equilibrium contract. And if you could tell which person was which type and the robust person walked into your office, you would just give him the option of buying the top sun contract. But again, the issue is you don't know a person's type because of asymmetric information. So whoever walks in, you just kind of have to tell them, these are the two contracts we're offering. Take your pick between the two. Okay, the reason this is problematic is because if you put yourselves in the shoes of a frail person, if you walk into an insurance agent's office and they give you two options of insurance to buy, top sun or bottom sun, well, even though the bottom sun is your equilibrium contract, you would be better off getting the top sun contract, because if you got that contract, then if you get healthier, you make more money. If you get sick, you make more money. So no matter what happens to your health, you would be banking it with the top sun contract relative to the bottom sun contract. And if they don't know that you're not robust, then you can be deceptive and just kind of misrepresent your type and really like make out in this situation by making more money by misrepresenting your type. The reason this would be detrimental to the insurance company is because if the frail types purchase the top sun contract, well, that top sun is in the unprofitable region relative to the frail types. So the frail types have this zero profit line that's kind of, it's flatter, so it's kind of the bottom leg of the triangle, if you find the triangle. And so in other words, the whole area above frail zero profit line is going to be an area where if an insurance company sells frail a contract in that area, the insurance company will suffer loss. That top sun is in the unprofitable region when we use the frail zero profit line as the pivot point for profitability versus losing money. Okay, so here's where we kind of end up in a jam again, because last class things seemed optimistic. We found this equilibrium where the market could avert a death spiral if everybody got their full fair contract. But now we've kind of introduced another reality of the world, which is people differ in terms of their probabilities of getting sick. And there's asymmetric information, so the insurance company can't distinguish who's robust and frail. And so when the frails misrepresent themselves, and they have all the incentive in the world to do that, the insurance company, again, ends up suffering harm because they're going to be losing money off of the deception that happens by the relatively sick people who could make money by getting, air quotes, getting the wrong contract. Okay, so the problem that this leads to is that there exists no pooling equilibrium. what is a pooling equilibrium? A pooling equilibrium is one single contract that both the robust and frail types would want to buy, and then at the same time would satisfy all the equilibrium conditions. So in other words, if we have these two suns that are offered, well, that's not going to work. But then the other problem on top of that is we can't kind of position one single sun anywhere in this graph where everyone, regardless of your health, would want to buy it, and it would be in equilibrium. Okay, here's kind of the coolest result of this chapter. The result is that there's kind of a trick we can play. And when this trick is played, then sometimes we can get a separating equilibrium. Okay, so what I'm going to do is, since separating equilibrium is a little bit abstract, I'm first going to show you where the separating equilibrium exists, and then I'm going to explain it to you so intuitively it makes sense. Okay, there's going to be a very, very specific location on the graph where we would get a separating equilibrium, so make sure you're definitely getting this correct in your notes, because if it's off, then the whole thing will fall apart. Okay, what we have, first of all, is a graph that has a full insurance line, so that's a 45-degree line that shoots out from the origin. We have a single big dot that represents the income combination that people would get if they were uninsured, and people have that same dot, so that's one dimension in which they're the same. But what we're also going to have in this graph is, because we have two types of consumers who differ in terms of their probability of landing on IS or IH, there's going to be two zero profit lines, and so these are going to shoot out from the dot and hit the full insurance line at different positions. Okay, here is where accuracy is key. So if you consider the frail type and you draw an indifference curve that belongs to the frail type, and you have it run tangent to the frail type's zero profit line and let it intersect the full fair contract for the frail type, then what you can do is you can offer two contracts that reside along this particular indifference curve, and these two contracts would result in a separating equilibrium. So contract number one in separating equilibrium is going to be the contract where everything jams up against each other. So in other words, the frail type's indifference curve hits the full insurance line, hits the frail type's zero profit line. Okay, that's contract one. The second contract is going to be located where this same indifference curve that we've drawn intersects the zero profit line that belongs to the robust type. So there's going to be two stars. These two stars, again, have a very specific location. These two stars are going to coincide with two contracts, which if offered, would result in a separating equilibrium. Okay, first of all, what is a separating equilibrium? The easiest way to understand this is in terms of a mental picture that I'm going to give you. It sounds super far-fetched, but it helps with kind of getting the idea of this to stick. The idea of a separating equilibrium is that the insurance agent can't tell the difference between robust and frail types. And so a separating equilibrium is one where if the insurance agent offers two contracts to someone who randomly walks in the door, then all the robust types would naturally want one contract, and all the frail types would naturally want the other contract. And so if the insurance agent just is careful in observing who picks one contract over the other, then he can kind of deduce what a person's type is without explicitly knowing it. So the mental story that I have in mind when I'm trying to understand this is, suppose you have a person who's blind and they can't observe so if a little fuzzy animal comes up to them, they can't tell if the animal is a cat or a dog because they're blind. Okay, so this is kind of like the asymmetric information. The insurance company is the blind man. He can't tell if a person walks in the door whether they're a cat or a dog or a robust or a frail type. Okay, the way the trick works, though, is that the blind person can take in one corner and he can put a pile of dog food, and in the other corner he can put a pile of cat food. Well, if dogs like dog food and cats like cat food, then the blind person can just set out these two piles of food that naturally attract different animals, and then at the end of the day, he can just figure out that all the animals over on the right must be cats, all the animals over at the left must be dogs, because the two things that he's offered just naturally attract different types, And so he doesn't need to have vision to see what the animal is. He can just deduce what the animal is based on what the animal has selected. So the same thing goes for the insurance agent. If the insurance agent is successful in offering 2 contracts that are consistent with a separating equilibrium, then what should be true is that when he whips out these 2 contracts for the person that walks in the door, all the frail types naturally go for one, all the robust types naturally go for the other. And now the insurance agent doesn't have to have this magical knowledge of what a person's health is by looking at the person, because they can just observe which contract the person has picked and kind of infer whether they're robust or frail. Okay, so what I'm telling you now is that the 2 stars are 2 contracts that would actually succeed in leading to this separating equilibrium. Okay, the way this works is, first of all, suppose you are a robust type. You walk into the insurance agent's office, you say, I would like to buy some insurance. The insurance agent can't tell that you're robust, but he whips out these 2-star contracts, and the insurance agent says, okay, which one of these 2 contracts would you like to purchase? Well, if you're a robust type, one of those 2 contracts is clearly preferred to you, and specifically it's a contract or the star that resides along your zero profit line. And the way we see this is if you take another set of indifference curves and you kind of run them through the plane, the star that sits on the robust type zero profit line is going to intersect an indifference curve that is higher than the other star. And so all the robust types, if they're offered these 2 stars, are always going to go for a particular star, and it's going to be the star or the contract where the star is sitting on their zero profit line. Okay, so far so good. So far all the robust types are going for one particular contract. Now what would happen if a frail person walked into the insurance agent's office? The insurance agent can't tell the person's frail. They whip out these 2 contracts, star 1 and star 2, and they say, okay, which one would you like to buy? Well, what we're going to say is for the frail person, both of these 2 contracts are sitting on the same indifference curves. So theoretically, the frail person is indifferent between the 2 contracts. They get no more utility from one relative to the other. But here's where, and we're going to do a little bit of hand waving, we're going to say that the frail types are probably consistently going to go for the star that sits at the intersection of their zero profit line and the full insurance line. Because theoretically, while it wouldn't make them happier since it's on the same indifference curve as the other star, that contract characterizes full insurance. And so they have no uncertainty in their life. That's kind of their equilibrium contract. So we're just going to kind of suppose that all the frail types would go for that other star. So the reason this kind of works to save the market from a death spiral is because we've taken account of the fact that people differ in terms of their likelihood of getting sick. We've taken account of the fact that insurance agents can't look at a person and tell how healthy they are. And now we have two stars or 2 contracts where all the equilibrium conditions are satisfied. So if all the robust types are getting the particular star that we've noted, well, that star is along the zero profit line for the robust type, so the insurance company isn't losing money on the robust types when they buy that. Similarly, when the frail types get all of the contracts that correspond with the other star, well, that other star sits on the frail type's zero profit line, so by selling that contract to frail types, the insurance company isn't losing money. So this is kind of the cool, magical result of the Rothschild-Stiglitz model, and that is that sometimes in the market we can have a separating equilibrium, and when we have a separating equilibrium, we can actually succeed in averting a death spiral and have an insurance market that doesn't collapse. Okay, that is the end of chapter 9, so we made it to the end finally. Again, make sure the pictures are always very precise when you're drawing this, because if you get things off, then things can fall apart quickly. I noted this to you earlier, but in the original class packet that I sent to you, Word kind of moved the location of the indifference curve. So it's sad and ironic that the one graph that needs to be like super precise is the one graph that has a typo in it in the original packet I sent you. So make sure you either make the correction that I noted, or you print off the new page that has the edited position of the indifference curve, because again, it's super important. So if you have questions about this in the next 10 minutes, reach out and let me know, and after that we'll meet back for the exercise. The final exercise for this chapter is you are going to try to recreate a situation where we have a separating equilibrium. So in the graph that's on the screen, and which will also show up in Blackboard, there is a series of indifference curves. Assume that those indifference curves belong to the frail type. Okay, what we're also going to assume is let's have a setup where there's two types of consumers. They differ only in terms of their probability of getting sick. So what that means is that both robust and frail have a sick income of 4 when they're uninsured, and they have a healthy income of 12 when they're uninsured. But the robust type only has a 25% chance of getting sick, whereas the frail type has a 50% chance of getting sick. Okay, for the first part of the exercise, I have taken this graph and I've made it downloadable on Blackboard. So just on your own, you don't need to turn this in, but this will be helpful for understanding. Just download the graph and kind of fill in the pieces so that you can recreate the graph. And then the bold text that's on the screen is what you actually need to turn in for Blackboard. So what we've got here is in the plot, which you can download, I would like you to insert the full insurance line, the robust person's zero profit line, the frail person's zero profit line, and then also the two contracts that would lead to a separating equilibrium. Okay, helpful hint. In order to do this, you're going to need to calculate each type's expected income, and then you're going to need to position in the plot two different zero profit lines, one that belongs to robust, one that belongs to frail. Okay, then using the indifference curves that I have given you in the plot, think about where two contracts would be offered such that we would get a separating equilibrium for the parameters. Okay, now here's what you need to turn in for credit for your exercise. So what you then need to do is indicate in the Blackboard blank the IHIS coordinate for each of the two contracts that are a part of the separating equilibrium. Also note which person, robust or frail, would select which contract. So this isn't the correct answer, but I'm just giving you an example here. What you would need to turn in would be something like the two income combinations that would lead to a separating equilibrium would be IH equal to 1, IS equal to 2, the frail person would get that. The other contract would be IH equal to 7, IS equal to 3, the robust person would get that. Again, those aren't the right answers, but that's kind of the format of what I'm looking for. Make sure this is super understandable. I know this is all quite abstract, but it's important to know for the exam. Of course, if you have questions as you're studying, reach out and I'm glad to answer. And then hopefully you all can go out and enjoy the rest of your day. I'll talk to you next class.